So my code agent now has an access to the virtual cat tool. I'm still using the GPT-4 mini as a reasoning power. So my agent 3 is live, and I am going to call this agent using .run, and I'm sending this to the cat. And that is given to the virtual cat tool, and the response is meow meow meow. An orange cat wearing a space suit. Run and open it. An orange cat, indeed, in a space suit. Hey there! If you enjoy my videos and find them useful, please help me reach 10,000 YouTube subscribers by subscribing and sharing this channel. It really encourages me in creating more AI and Gen AI content for you. You can also connect with me more on LinkedIn, GitHub, Substack, X, and Facebook. I share more about projects, insights, and updates there. Links are in the description. Moreover, I'm also building a crash course and a community about AI agents, the simplified version. Be the first to know and get an exclusive discount by subscribing to our YouTube channel and Substack channel. Links are also in the description as well. Let's do this. So before we actually dive deeper, I want to show you that it's possible to use Smolagents with Ollama. So first of all, I need to serve Ollama. So now Ollama is live, and actually let me move it here. The reason I'm running this right now is that I figured that Ollama takes a lot of time in this run. So I will run this first and revisit this afterwards. Anyway, all of my API keys is contained in the .env file, and I can load it to where I want. Now, in this code here, I am going to talk to Ollama, the light LLM class, as is as simple as provide the model ID. So I'm going to use DeepSeek 14 billion parameters that has already been downloaded to my computer. And this is where the endpoint of Ollama is. So you need to make sure that you provide that to the API based argument. Ollama has no API key, so we can leave it empty. And I specify that I want Ollama to have the context length of, let's double that, around 16,000. So when I run this code, Ollama should be, well, it's okay now. All right, now we have model locally, Ollama serving DeepSeek. Now the first task is, let's see if it can give me the number 6 of the Fibonacci sequence. And I specify that, okay, use Python coding to do this. Your code should have a print answer so that you get the answer out. Respond when you get the answer done. So I have imported CodeAgent, and my agent is instantiated easily with CodeAgent. No tools provided specifically, but if you see here, the base tools are triggered. And the base tool includes web search like DuckDuckGo, Python interpreter, and what is the other one? I don't recall the other one, but I think it's like speech, text to speech. I'm not sure. But yes, and then I set a maximum number of steps to 3. Okay, I am going to run this, and we are going to jump to another Jupyter notebook so we can go through faster, because I'm going to switch to a GPT-4 mini instead. And by the way, I plan to upload this repo to my GitHub, and you can have access to all the notebooks here. All right, so here I have commenced the the code agent. Now Ollama is handling memories and model upload now. So we'll leave it for now, and we'll come back later. And actually, we are going to start with the basic repo here. All right, this basic repo is going to go through a lot of concepts that we covered the model, the code agent, tool, Python interpreter, and eventually the multi-agent systems. So let me import everything I needed. Now, this one is not used, but let's leave it there. It doesn't do anything. But what I want to use here is the GPT-4o mini, and I contact to with the OpenAI server via this class. All right, now we are good to go. I am going to ask the same questions to the model like before. What is the sixth number of the Fibonacci sequence? It's the same prompt as you have seen before, but now we are just going to run it with the model OpenAI. Here we go. So now it has started. Step number 1, the model gives me this code and it has run it, and the answer is 8. That's it, final answer. So I have given it a response. So actually let's print response. Here we go. The sixth GPT-4 mini agent told me that the sixth number of the Fibonacci sequence is 8. So let's actually come here. This is the actual Fibonacci sequence that I wrote manually. That's 1, 2, 3, 4, 5, 6. Oh, the answer is 8. So it means that the 1 is actually 1 here. 1 is 1, 2, 3, 4, 5, 6. So if I said 7, what is it going to do? It will answer 13, which is right. Okay, as you can see here, the code agent is very simple. You provide a tool, you provide the model you need. You may want to use a base tool and you can specify the maximum number. And with a model smart enough, like a GPT-4o mini, for this particular case, you will get here. The model reasons, write a code, and the code is passed out and executed, and the model got the answer and returned it to us like this. Okay. Now, in terms of tools, there are default tools or the base tool, as you can see here. Actually, to give you a better understanding, we can actually go to the default tool page. It's going to be at the bottom here, reference tool, and you can see here this default tools. You have Python interpreter tool, final answer, user input. You can have like a step where you can provide additional input to the model before it has finished its task too. DuckDuckGo search, it's free, but you will have some rate limit. Google search tools actually works. Underneath is the SERP API. Whether here is it? Here we go. Underneath, it's using the SERP API. So you need to have the SERP API key. So these are the default tools that the model has when you provide. You tell them that it can access the default tool. Okay. I'm just going to show you a few tools here. First one is a DuckDuckGo. You instantiate the class and you can give a query and you can run it. Oops, I need to import this first. I imported this, instantiate and run again, and then you will get your result here. The search result is actually a text, but in this text markup file format, you have links in it. So later on, your agentic system can pick up this link and search for the information. This is what we are going to demo as well at the end of our video today. All right, now the next tool is the visit page tool. This visit page tool will actually do a web scraping using a request module. And yeah, it's going to extract the HTML content from that page. And this is tools, guys, built-in tools. Now, for customized tools or custom tools, you can do with the add decorator, or you can do it with the subclassing. And we are going to take a look at both today. Now, for the add decorator, you need to import this decorator first. And This is my dummy function. This is a virtual cat. I want this function just to return meow thing, right? Acting as a virtual cat. So first of all, you write a good function, and you must write a descriptive docstring. You need to do this because your agent needs to know what tool is good for what purposes and how to use it, right? So make sure you spend a lot of time testing this with the agent. And I can tell you that before this video, I prepared for the content. I spent like hours tweaking the prompt or the docstring for the tools and the agent. They are crucial for building a performing agentic AI application. Anyway, so this virtual cat thing will receive a string called interact. So whatever interaction you want to do with your virtual cat, it's going to be a string, and it's going to return just meow, right? That's it. So that's tool. Now let's test that out. So my code agent now has an access to the virtual cat tool. I'm still using the GPT-4 mini as the reasoning power. I turn off all the tools, all the default tools, and I have set the maximum steps to 3. So my agent 3 is live, and I am going to call this agent using .run, and I'm sending this to the cat. So what is happening here? Now the tool got triggered, and you can see here that my actual string is all cute cat pat pat is different from the interact string. And this is because the model has reshaped my string. So it has reshaped into a string that the model thinks is appropriate, and in this case, the pat pat only. And that is given to the virtual cat tool, and the response is meow meow meow. And the final answer is, well, meow meow meow. And again, you see that the model has actually changed this a little bit. The tilde actually, or whatever it is called, are actually gone. The models also intercept the response from the tool and reshape to its liking before it's actually give me an answer, right? Now you can see, just to repeat again, my input text is not the text that the tool will get, because in the React framework, the model would think what it needs to do. Therefore, it has its authority or agency to change or adapt to whatever it needs. And in this case, it has transformed my initial request to just a pet pet. Now it has reasoned, now it needs to act. It acts by calling the function. And when calling the function, it gets observation of the result from the tool. And then the LLM, the AI, has its agency or autonomy to actually take the tool's output and change it in the way that it wants before it give it to me. And that's why you were seeing that the meow 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 is not the one that the tool produces. Anyway, that's just how the AI works. Marching on to the second way of implementing tool, subclassing. Subclassing is simple, but it's powerful when you want to customize or have more flexibility in your tool. First, you need to import a tool class from Smolagent and just write another class inheriting from the tool. In this case, I am writing the virtual dog here. You need to give it a name. You need to give it a good description. You need to specify the inputs that it needs. In this case, it needs an interact, which has a type string, and the description of that, right? And you also need to specify the output type as string as well. Now, this, you have to have a forward function. It's similar to how the virtual cat works. It's just going to answer woof. That's it. That's the class of the virtual dog. So in order to implement it, you need to instantiate it. You can't just use the class. You need to give an object a tool object. And this is how you do it. You instantiate it. Now this code, this agent has both the tools for virtual dog and the virtual cat. Everything else is the same here. So I have my agent here. So first I am going to ask it to react to all cute dog. So it thinks that, okay, now it needs to use the virtual tool for dogs. I'm sorry, the virtual dogs, and therefore it will get the woof 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 back, and the final answer is like this. The dog says, well, fair enough, that's good. Now, let me play with cat. Use the same thing, same agent. It should trigger the virtual cat tool. Well, it works, right? I think this is because both the tools have reasonably good enough descriptions for the GPT-4o Mini to call respective tools regarding cats or dogs appropriately. That's pretty much it, right? Now, before we finish the tools section, the last type of tools that I want to cover is tools that you can import from HuggingFace space. As an example here, you can use the tool class and use a method from space to do this. And you need to go find a space that is actually live and running. As an example here, we are going to use space from the Black Forest team. It's hosting the Flux.1-schnell version. And this tool allows you to create an image from a image prompt, right? I'll give it a good name, like image generator. Description is generate an image from prompt. This is a tool, and we are going to run the tool with this prompt, a sunny side up egg. And let's see how it works. Might take a while before we get the answer because it now needs to establish the API and wait for the Black Forest models to actually produce an image and send it back to us. But now it has completed its thing. Now, the point is, for this function, the response is actually a path. This is a path that has the image right here. So I want to show that image. So I'm going to import image from pill and open it up. And this is the sunny side up egg. Well, it's good enough. Okay. Now, to pack the tool into the CodeAgent is the same thing as before. CodeAgent tool, and you put the image generator tool in it. And for now, toggle all the base tools off, and the model is still the GPT-4o Mini. So this agent is now created, agent 6. Now, what I want to show you here is how to use the additional arguments. This is your actual prompt, right? But you want to add additional message to it. And in this case, it's the user prompt. You actually instruct that, improve this prompt, and then generate an image. And this will actually, this sentence or this phrase is actually to make sure that the model, the agent, will generate an image. But what this prompt is, you can add an additional argument like this. Additional argument, user prompt, an orange cat wearing a space suit. And when you run this, it's going to reason. First, I need to create a better prompt. And this is a prompt that it gets. And only after that, it will trigger the image generator and give the prompt to the image generator. Now it's done. We have the file back. So we can run and open it. An orange cat, indeed, in a space suit. It's pretty cute, actually. All right, now to the next part, let's talk about Python interpreter. I want to show you that it has an upgraded security. So in the case that we are going to ask the model to give us a title of the given URL, and we are forcing or instructing the model to use request and beautiful soup, and we give the URL like that. Well, let's actually change it to number 7 just to be clear. All right. If I just do this, we are hitting with a error. And the error is here. Warning to user, code execution failed due to an unauthorized import. Considering passing said import under additional authorized imports, and this is its recommendation. And you can see that the only valid import right now is statistics, stat, iter, tools, random. So to follow its instruction here, we are going to add the additional imports like this. Because we know that we are going to use request and beautiful soup, we will just add those imports in this argument. And let me just change them to number 8 as well, and we are going to run it. All right, let's see what is happening. Now the model wrote me this code and will try to execute, and it looks like it has executed successfully, and the title is returned as Agents Guided Tour. That is great, and that's the answer, right? Yeah, Agents Guided Tour. So now this code is run in my local machine, and it has an added security so that you don't import packages or modules that you don't prioritize. Oh, sorry, you don't authorize. All right. Well, we have come to the last topic of this notebook, and this is the multi-agent systems. It's a little bit complicated, so let me walk you through carefully. First, I have a cat agent. The cat agent has the virtual cat tool, the same as what we did before. But now I give it a name, cat agent. And the description is, this cat agent is going to send interactions and get response from cats. Use this agent by asking it to use tools and specify interact. Now, you see that I got it to specific prompt, and I actually spent a good 30 minutes tweaking because I didn't get the response that I think it should. So being specific, even specify how to use the tools, will make your system much better. Similarly, for a dog agent, we are using the CodeAgent. We provide the instance of the virtual dog tool class, and we follow with the name and the descriptions accordingly. Now you have two agents that they will be managed. So you need a manager agent. The manager agent is still from the code agent, and it will know what agents that it needs to manage. And you are going to use the managed agents arguments to accomplish that. And because the manager agent will need to handle complex tasks, more complex tasks. So make sure you provide with enough maximum numbers of steps. So I have made the manager agents now. So let's see how it's going to handle this. I want to say hello to the cat and the dog. So what is going to happen? Wow, it's going to execute cat agent task. This is strange. Never had that before. We didn't have this task. We only have interact, so this is going to be bad. You run cat agent. Now the manager agent thinks that it needs to do that, and now it's the cat agent turn to do things. And the cat agent actually used correctly. The interact now get say hello. And the cat responses should be meow 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 as usual. Step 2. Now it's actually ran into an error. Error in code parsing. Well, code parsing, the way it works here is that the agent will construct its reasoning, and sometimes it will write code. But if you want the tool to be the code to be triggered properly, you need some way to parse or extract the code out. So if the answer do not write a code in specific format that the extraction tool is written to extract, you are going to run into this error. But that's up for the model to correct itself, right? That's the beauty of the agentic system. If it runs into error, the retry mechanics will kick in and force the model to do it again. The cat now is responded perfectly. Now the dog agent start now, and it has this virtual dog thing, say hello, and we got the wolf 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 back, and the final answer is here. Now the manager agent is trying to pack everything into the answer, right? Or I don't know why it got back to the cat again. Say hello, step 1, step 2. All right, we arrive at the final answer, which is virtual cat responded with the sound meow meow meow. The dog responded with a playful sequence of barks and actually just removed the wolf out. Great. Anyway, that's the side effects of using AI agents. It has agency and authority to do things that it thinks appropriate. And actually, before we continue, take a look at this. Your token consumptions is going to go through the roof. And this is just because it is agentic systems. It will keep chatting, it will make mistakes, and you need to redo it again. Therefore, you are going to consume a lot of tokens, and that is going to be expensive. Therefore, it's also recommended that avoid AI agentic systems if you don't have a lot of money. Okay, this is just for a nice touch. The small agent has a gradual user interface for you to play with. You can just import this and add your agent to this function and launch it, and then you have it to go. So I can actually copy my prompt here. Now I am interface, right? Oh, I can't paste. I'm sorry. Say hello to the cat and feed scratch the dog's head, something like that. It's going to do its thing underneath, and when everything is answered, it will show. So yeah, it's not streaming for now. Oh, actually it did. Okay, it's actually streaming. Step 1, thought, finish the new task. To accomplish the new task, I first interact with the cat and say hello, and then I will interact with the dog to perform the action of scratching his head. I will utilize the cat agent and for the cat and dog agent for the dog. Wow, it's so okay. It's streaming, and you can actually expand this guy to see how it works underneath, even execution logs and whatnot. So yeah, with the gradual interface, you have a nicer way to actually see how the flow, the agent has reasoned and commit actions. The final answer, the cat response was cheerful series of meow with a tutor. I think the tutor is because the strike through is because the tutor. When a scratch a dog hate is respond with a playful box. Anyway, I think this is successful. So all in all, the small agent repo is packed with goodies, and you can make your multi-agent or even at least a multi-step agent very, very easily. Let me interrupt this. Before we move on to telemetry or traceability, let's revisit our run with Ollama. So just to review what happened before, I load this and I made a connection with Ollama. So the model is going to be served by Ollama running in my local computer. We are going to use DeepSeek R1 14 billion parameter to solve the Fibonacci sequence here. It took 2 minutes to finish it, while if you can quickly go back and take a look, it actually took GPT-4o Mini 4 seconds, but 2 minutes for my local computer, MacBook Pro, M4 Pro as well. Right. Anyway, so this is the code that it has triggered, and the answer is 5. So fifth sequence, it usually think of 0 as the first one. So 1, 2, 3, 4, 5, 6. So the sixth sequence is 5. while for the GPT-4 Mini, the sixth sequence is 8. So it has its philosophical differences between what's the first element of the Fibonacci? Is it a 0 or is it a 1? But it works. So this just shows you that it's possible to use Ollama, running an open source model on your local computer, to work with the small agents repo.